Hi, my name is Lisa Richter. I'm the Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help system integrators build better businesses. How do we do that? Well, for starters, we have a team of volunteer system integrators who have crowdsourced a best practices manual to help system integrators scale their businesses. In fact, the BP committee just released a beta version of the latest manual 6.1. CSA also offers a certification program and other resources, including professional development, learning from peers, access to vetted professional services companies, including insurance and legal, who understand the SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customers' pain points, monitor industry trends, and share your thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps system integrators, industry suppliers, and manufacturers connect and do business. For system integrators and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources from accounting to sales to operations 365 days per year. It also means you and your team can attend the CSIA conference because this annual in-person event is members only. If you are currently a member, thank you. And please keep in mind that it is renewal season. So if you haven't renewed your membership, please check your inbox for the renewal notices. If you want to just get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation, and it's a great way to hear what your peers are up to. One last housekeeping note before I turn it over to today's speakers. If you have any questions during the presentation, please use the Q&A feature in Zoom. You're welcome to chat amongst yourselves and use the chat feature, but if you put those questions in that Q&A, that helps us just stay organized here on this end. The session is being recorded, and you will get a link to the recording in the next day or so. And at this time, I'm going to turn it over to Hal, who's going to kick us off. Take it away, Hal.
Thank you, Lisa. Good morning, everybody. As mentioned, my name is Hal Chastro. I am the Director of Industrial Automation for Graybar Electric. And today I have the honor of introducing Grant Lasur. He's the Senior Director of Solutions Management for Schneider Electric. And Grant's going to be talking about automation engineering efficiency using IEC 61499. But before I introduce Grant or give the microphone to Grant, I would like to provide just a quick overview of Graybar Electric. As many of you know, Graybar is a leading distributor in North America. We distribute industrial, automation, electrical, communications, datacom, all these types of products. And we're a supply chain management and logistics services as well. We've got a network of over 325 locations across the U.S. and Canada, and we support approximately 146,000 customers. Now, I'm part of the industrial automation business units that works with many manufacturers, OEMs, control system integrators such as yourself. We've got a strong team that's focused on the industrial automation applications and the control system integrators in particular. We joined CSIA about 4 years ago and have been very impressed by the tools, the thought leadership, and the resources that CSIA has provided to help its member companies to support growth in their business and address even the evolving trends in the marketplace. And now I have the pleasure to introduce Grant Lasur. He's the Senior Director of Solutions Management with Schneider Electric. Grant, take it away, buddy.
Thank you very much. Sound check, Hal. Can you hear me okay? Thank you. Let me just share my screen and we'll take it away. Share. So that looks like that is now functioning, and I will like to just give me 1 second. Let me just call up the Zoom chat. Yes, thank you, Hal. Thank you, Lisa. It is indeed a privilege to be addressing you all here today, and thank you very much to Graybar for sponsoring this event. As was mentioned in the introduction, I'm here to talk about automation or engineering efficiency, and of course, we are specializing in a new control platform that's centered around a slightly different standard or an evolution of 1131 kind of control automation solutions, and that's the 61499 standard. Now, much of what I'm going to talk to you today about is really some ground truth. These challenges for engineering efficiency are the same whether you're talking of a proprietary DCS, PLCs based on 1131 or 61499. But I do want to just give it a little bit of color around how I think we can make some really major breakthroughs if we consider 61499 as a technology. So we'll walk through a few lessons of the past and what we're doing to help enable engineering efficiency. And I thought I would include a little piece about where I see artificial intelligence playing into this equation as we move forward, and closing it all out with a summary. A little about myself. I was raised in New Zealand and started my working career there as a system integrator, working with Alan Bradley at the time, Rockwell, and Modicon, Interlution, Wonderware just came on the scene, as well as Foxborough. And I've really worked in a wide variety of industries and a wide range of project scale, from a small single unit automation project, discrete, to a fairly significant distributed control, safety system implementation in some of the world's largest refineries. So that's covered pulp and paper, food and beverage, and oil and gas, including one interesting project in India, which is indeed the world's largest refinery, and that was rather impressive. So what I want to do is to be able to bring some of the lessons that we've learned in these various projects and just talk about how we can take those learnings and implement them in an offering that I believe will make some significant impact in improving engineering efficiency, reducing risk, and ultimately reducing rework, improving everyone's bottom line. Before I do get started, I do want to just make a short plug for Next Gen Automation with universalautomation.org. This was a prior session conducted by CSIA and sponsored by Graybar. So if you have the inclination, by all means, jump on the YouTube channel and go back and look for that particular session, because that gives you a little bit more background in what 61499 is all about. So just before we get into some of these lessons, I do want to just touch on some of the core values of what we're doing with 61499 in an offer that we call Automation Expert. A couple of core characteristics of this solution, again, based on 61499, is it enables us to create a function block set that would enable everybody to create their own libraries of standard function blocks that are completely agnostic to any particular control system. So you could run these function blocks on a Schneider Electric PLC or any other PLC or control platform for those members who belong to universal.org. That's why that piece was important. And in doing so, that means that we can leverage proven in use, and we can finally stop reinventing the wheel by having to always create control system strategies or control solutions as if this is the very first time. So you could imagine then that using this concept, you could have a standard function block for 3-element boiler control. You shouldn't have to reinvent that control strategy every time. You shouldn't have to reinvent control strategies for heat exchangers or more complex process units. So this is really just serves as a reminder of what some of the core value principles are of Automation Expert and 61499. So getting into the analysis or breakdown of automation engineering, working for Schneider Electric or for Foxborough specifically, historically for many, many years, we have the benefit that we have our business systems that we can measure time and materials and work breakdown structures of how engineers spend all of their time working on projects. So at least in a safety PLC kind of domain or in a DCS kind of offering, we see that these tasks are generally how it's broken down in terms of share of time spent. We have a large, depending on the project, we have a large amount of our time dealing with administration and management, around 27%. Cabinet design and cabinet building, around 4%. Control configuration is 17%, and the HMI design is around 15%. There are always some custom tasks. You might have to create some custom reports or interact with some other business system. So that takes up a significant share. And then we see another big chunk of the pie here associated with system testing and checkout. So if we look at the large share of control configuration and HMI design, you can see that that total is over 30%, 32% of the total job share of what we spend our time doing is implementing that kind of, doing that kind of task. And of course, if you're a system integrator that works with different types of control platforms, then your teams are having to learn different kinds of tools. And some people might be more proficient with brand X's tools than they are with brand Y. And this is really where this notion of using 64099 and have a control programming language that is platform agnostic really starts to offer some benefits, so that as our teams become more proficient, they can deliver on using the same libraries and the same tools over and over again. So what we've learned, however, is it doesn't take long before you just dragging and dropping and fat finger typing into an IDE of kinds, before that starts to have before it just doesn't scale very well. And we've spent many years looking at how can we use some automation techniques or automated workflows to try and speed up these kind of tasks so that people can spend more time doing more valuable elements of control system engineering, whether that's checkout and testing or whether that's working on more complex loops. So within Ecostruxure Automation Expert, we have a suite of features which we just call Asset Link. It does a variety of jobs. But first and foremost, the main job that it does is it allows you to instantiate controls based on data, external data. And this data could come from piping and instrument diagrams, or it could come from spreadsheets. And in our particular case, because our sister company is Aviva, and Aviva Engineering make a comprehensive plant design tool suite, we could also connect to things like Aviva Engineering, or for those who might be familiar with a competitive offering from Hexagon that does a similar kind of tooling. So that's really been our goal, is to see how we can reduce the amount of time spent doing highly repetitive, non-value tasks in this control configuration HMI design area. So we continuously do additional research. So I shared with you some of the WBS breakdown from our business systems. Your results might vary, but generally speaking, most people have agreed that in orders of magnitude that we're about, we all look quite similar. But more recently, just this year, we've done more research looking at pain validation, and 60% of customers surveyed agree that analyzing documents required to build a system are very difficult and certainly not standard. So we're exposed to a high degree of variability when we go from one project to the next, because we can't always rely that the quality of documentation is going to be the same going from one project to the next. Depending on who we're working with, or we might have our own libraries, but not everybody has a standard set of proven and use libraries. So if you're starting a project and you don't have that agreement, then with the end user, then you spend quite a lot of time doing a front-end design validation, just confirming that you either understand the customer's preferred libraries, or the customer understands your libraries and agrees with your logic for motor starters, agrees with your HMI conventions and so forth. So there's a lot of negotiation that goes on. But surprisingly, we do find a lot of people don't have any standard libraries at all. So every project they do is starting from scratch. Other areas of pain is certainly around the lack of documentation or even producing documentation. Often on projects that I've been involved with, the customer has given us the latest set of data sheets and P&IDs, and you inevitably find that they are many years out of date. And then you eventually find that on the job that some corrections have to happen, and that introduces risk. So we also included some questions around AI. How willing are people willing to use AI as part of their tool chain? And a very high percentage expressed that there was no hesitation, except they didn't want that to be a hands-free approach. Of course, when we do automation projects, at the end of the day, we still have to do test validation, and we still need to verify that our automation solution addresses the design intent of the plant engineer. Other concerns around AI center around data breach. People don't want their IP to leak into the wild, and there is, under all cybersecurity best practices now, very strong provisions around making sure you're keeping people's data private, and there's a number of regulations that ensure that we don't share personal contact details inadvertently through web-connected tooling. So that just sets the table a little bit to describe some pain points and where and why we've been focusing some time in trying to relieve these pain points to help us become more efficient and deliver proven and trusted control solutions in a more timely fashion. So where does it all start? Well, the goal of automation is to control and manage a plant in the manner that meets the design intent of the plant designer, so it can operate profitably and safely. And we've been doing this I've been doing this for over 30 years. But over those 30 years, not a lot has changed. And I just wanted to show you what I believe are the world's most popular automation tools in this context. Number one is a good highlighter pen. And number two is a good spreadsheet. Of course, back in the day, we might have used DBase 3, if you're my age, to capture some of these details. But what we invariably do with these two tools is we use the highlighter pen to go through pit piping and instrument diagrams, reconcile them with instrument data sheets, and we also, if we're lucky, we might get a functional a control narrative or a URS. And we put all of that information together, and then we start to program the control system of choice and create the the operator interface in the control system of choice. Now, if this data sheets are any good, it would tell us what the calibrated ranges are of sensors, the kind of actuators you have. Is it air to open or air to close, spring to open, spring close, whatever, fail safe, fail to open, fail to close, those kind of informations, and alarm set points. We can generally see alarms on piping and instrument diagrams, but we don't get to see alarm settings that normally has a context of engineering units. So we spend a lot of time processing all of this information. And then as control system engineers, what do we have to do? We have to come up with a hardware architecture. We have to allocate signals to I/O, make sure that the I/O is suitably distributed so we can pick up all of the signals in the field. We need to understand then the control intent. What does the control system have to do, and how should the operator interact with the plant? So then we set about programming the control system and the HMI and testing commission. This, by and large, is the end-to-end workflow. Now, if you sometimes you might be working on a project with a control platform and an HMI platform coming from a different vendor. So we could have, for example, and I'll use one of our own products, a Modicon pack, talking to an HMI, let's say from Aviva, formerly Wonderware, InTouch. So now we're going to have two different skill sets of people, programming a PLC, drawing some pictures, and then connecting those two things together using something like old days Modbus or new days OPC UA. And you kind of think, well, in order for those two things to come together, it'd be really great if we had some standard libraries and that those two items came together the same way over and over again. And that's exactly what we do when we create templates. We create a homogeneous object that describes both control, HMI performance, historian needs, and create that object. And then as we instantiate that object, we deploy it into a pack controller and onto the HMI platform as a single step. So that's what we do. If matter of interest, that's what I looked like 30 years ago working in Germany. So a little bit about Asset Link. So the whole idea here now is that we can take an object and we create, and I'm not sure if I really am a big fan of this term, a digital twin of the asset that we're controlling. So let's say it is a power plant. Then a power plant might be made up of a deep water treatment, demon water, fuel handling, combustion, steam generation, electrical generation, and so on. So we would model those process units as physical assets. And then within our tools, at least, you would define the runtime controls and the HMI for those items. And then as you instantiate those assets, you will be programming the control system by instantiation. And that's, in fact, how 64099 and Ecostruxure Automation Expert works. It's an object model where you can consolidate all of these facets of automation into a single object representing this physical asset, and then you can deploy that asset as many times as you want. If you have 3 boilers, just some that are identical, just instantiate your library for the boiler 3 times and you're done. But as I said, there's a lot of engineering data that has to cross from design intentions into our tool chain. And as I mentioned earlier, we have design tools for doing that, particularly from Aviva. But in its simplest terms, even if you don't have all of this stuff in the top layer, you might just have Excel spreadsheets and a reliable set of Excel spreadsheet. So our tool chain will consume that data. You can then assign some kind of template to every instance, and then from there, bulk generate the control system. So the idea here is if we're using the same library templates over and over again, we can be assured that we're going to get a known outcome. And if you have used these libraries before, then you can take some confidence that through proven in use, that you know that a level control loop works just fine. You've used it 100 times, and you've tested the heck out of these loops before. So you can start to relax what your test criteria starts to look like. So that's essentially what we're just trying to do here, is to use a rules-based approach to bulk instantiate. So taking that fancier diagram and saying more succinctly, we can take the instrument spreadsheet as an IO list, pull that into our tool chain, and using that tool chain, we will assign some kind of function block template. And then from there, we can instantiate the templates for the controller. And as we instantiate those templates, it will also generate the HMI. And the HMI will be linked. We don't have to even know what the intermediate signals are between the HMI and the controller, because those were defined in our templates. So just a very simple three-step process. So it does get a little bit more complicated than that, though. When we look at this in the context of a process and instrument diagram, we've got to be mindful of not all loops are the same. So loop 1 in this example is a temperature control loop. So we have potentially a thermocouple or an RTD coming in from that temperature sensor. Probably nowadays it's going to be 4 to 20 milliamps, but we might have to do some signal conditioning on this guy to get actual temperature. And then this steam valve is going to be suitably sized. So with a temperature control loop, these are generally they respond more slowly than other kinds of loops like flow or pressure. So we might apply a suitable set of PNID tuning for this slower responding loop here, that's temperature. We have a level control loop, loop number 2. That's a level indicator or a level transmitter connected to a level control valve. So we'll have a different kind of configured loop for this guy. And then over here, we've got another loop 4 is another level loop, and loop 3 is a pressure control loop. So you've got those 3 things. And then what I can do, because I have a true object model, I could wrap this entire unit and just call that an evaporator unit and make that its own function block. So now that it's a composition of these loops, function blocks making loops, loops making process units. Within the Ecostruxure Automation Expert, essentially then these loops will just look like any other function block, but they will be different in some ways. As I've mentioned, one example, the tuning parameters for temperature would be different than they were for pressure. For level control, if this was an irregular shaped tank, and we were measuring level using a differential pressure transmitter, then we would have to linearize the pressure. We would have to compensate for the shape of the tank in some applications. So as you can see, there's a lot of variation. So we spend our times doing a lot of tuning and tweaking. But if we do the job right, we are very confident that we can automate this quite easily. Sometimes you might hear me or refer to a CAT. And I just wanted to let people know that in the world of Automation Expert, a CAT is really a euphemism for a function block. But it's a little bit different than traditional function blocks because it's a composite application type. And I can embed different CATs into other objects and making other derived CATs. As I mentioned, I could have these 4 loops be stored as a CAT and then wrap them all up as a separate CAT, which I then call the evaporator CAT. So in 64099, we support the notion of composition so that you're not having to always be at the most granular level of control system programming. So some of the facets of our bulk engineering tool, as I mentioned, we're able to bring that data in from different sources. As I've mentioned, we could bring it in from Aviva Engineering, or we could just bring it in from a spreadsheet. And we can also bring data in from piping and instrument diagrams. I'm not sure if you're aware of this, but there is a standard XML amongst tools that make piping and instrument diagrams. That's called a DXP file. And we can use that as well. That's a very useful file to have. It basically tells us how to build the operator HMI. So with these 2 input sources, we can do a lot of good. So we import that data. We map each entity that we find in the spreadsheet to a template, and then we generate the control solution. It's basically those 3 steps. This is in fact the user dialogue that you step through to go through this process. As I mentioned, we generate the CAT instances based on a plant hierarchy. You saw me earlier, I'd mentioned we have smaller control blocks that then become part of a control loop, multiple control loops becoming part of, in that case, an evaporator, and in this case, alum storage, a part of an alum dosing system, and that becomes part of a water wastewater treatment plant. So this idea then, we do have to have this notion of a hierarchy, because that's the way the objects would then be composed. We then use this rules-based template association, and we are able to manually break those rules. And when I say rules, if I go back to this prior example, if I have an entry in my instrument list that says level transmitter 100 LT001 and 100 LCV001, I can tell that those 2 things are a loop, they belong together, but the L tells me that that's a level control loop. So I can put a little rule in my engine that says, hey, look for everything with an L in it, and then use the appropriate level control loop template. Look for everything that might have a P in it, then use the pressure control valve typical or function block template for that loop. So when we create rules, it'll automatically assign the right template based on your rules for doing the instantiation. And here we can see a little bit about how we configure what we're looking for to trigger those rules. Is there a certain combination of I/O signals? Do we have certain values in certain fields? It's very expressive, but once you've defined the rules, it very much becomes a plug and play, load and go kind of situation. So here's a little demo that I've created that walks us through this process. So here's a spreadsheet. Here we can see the plant name is water treatment plant. It's desalination, and we're working in the chiller. Here we can see a number of instruments flow switch, flow transmitter, HV, some limit switches here, and we've got different types of signals and engineering ranges. I can see that row 10, for example, is a flow indicator. It is 0 to 150 kilograms per hour, and the loop number is FO2. So my rule will probably see that that's a flow loop and apply the right template. So let's just see this play out a little more. So here we are in our engineering tool. We're going to just make sure that we've got the plant model that we want to use. I can change this model if I want. This is using S88 kind of convention, plant name, area name, unit name. That's kind of essential to set up the number of levels in our hierarchy. And if you don't like those particular classes, you can create your own. Now we're going to just select an Excel spreadsheet, pick it from our drive here. We're going to import it. Now we could see that structure we saw in the spreadsheet, those layers, water treatment, desalination. Here's all of our individual loops. And then you can see here that the templates have been assigned to each of those instruments using the rules that we defined. So here's a digital input for a flow switch, for example. As we scroll down, we can see, oh, we've seen a tank. So now we have a cat that is for a tank. But if I don't like a tank function block, I can always override what the rules said it should be. And in this case, I've got a variant of a standard tank, and I've changed it to an inlet storage tank. So step 3, here we are, just about to hit the generate. And once we generate, all of those function blocks or instances have been generated. Flow switch 01, they have had all of their attributes programmed based on data coming in from that spreadsheet, including the ranges, the alarm limits, and so forth, the signal types that it's required. And then the next step is if we hit another button, in our case, we can sync up to Aviva system platform and generate the HMI linked to the controller because we defined the HMI symbol, all of the signals as part of the template, and now I have generated my HMI as well. And we know that the connection between those two things has happened automatically, and we've defined it, we've tested it 101 times as well, so proven in use, and I think we've managed to save ourselves a lot of time in the engineering workflow. So that's basically the process of what we're doing. Oop, I've dropped out of presentation mode here. I did promise that I would just mention a little bit about, well, how do we see AI playing into this game? I'd mentioned at the very beginning that one of the things that we do is we go through paper P&ID diagrams. We use a highlighter pen to do material takeoffs. We have in fact created a AI that can scan and digitize P&IDs, even if they're cruddy old paper ones, and it'll do some symbol recognition on the symbols, and it'll extract the loop numbers, and we will create from scratch, from cruddy old drawings, this DexP file that I mentioned. So within our tool chain, we have this ability using some kind of machine learning to do that. Our longer term plan, and this is a process that I'm leading within Schneider Electric, is that we do, in fact, expect to be including a co-pilot GPT kind of wizard within the IDE of Ecostruxure Automation Expert. And here you'll have the benefit of having all of the documentation, all of our hardware documentation, as well as best practices and how-to guides built directly into the tool. So we'll be able to ask the co-pilot about how a particular function block might work. We could ask it to generate a new function block to do a certain task. And one of the things I'm looking forward to is being able to use this kind of capability to do something a bit more than cookie cutting function block templates, where we might get to a point where we could say, ChatGPT or Copilot, I would like for you to create a sequence that transfers product from this receiving tank through this valve manifold to this line and deposit it into this receiving tank on the line and have it create an SFC. These are the kinds of jobs that we can't rely on templates. We still rely on human beings and a high cognitive load. But I'm very encouraged that we'll be rapidly coming up to a point in time where we can use large language models to help generate that kind of content in the future. So the benefits of eventually using an embedded GPT is, as I've mentioned, being able to bring people from newbies up to experts very quickly, to be able to access best practice knowledge and workflow, to assist with workflows and so forth, and just help continue to drive engineering efficiency. So just coming up to the end here now. So key summary, 614.99 Automation Expert enables us to create a control solution that's hardware agnostic. And the benefit of that is I could use anybody's hardware. And if the hardware goes out of date, I can move my control logic from the older controller to a newer one without having to revalidate the control logic. This is a big one, particularly finding a lot of favor in life science industries. The engineering workflow, we're kind of expanding the access or utilization of data, trying to eliminate the need for a highlighter pen and spreadsheets and connect directly to those data feeds and use that data together with some best-in-class libraries to just generate controls and operator HMIs. One of the benefits of this approach is that we stay connected to the data. So if we rerun the workflow and we see that 3 new valves have been added, then I can run a diff and expand the plant based on what has been added since we initially done the project. So this workflow can stay evergreen, staying track with changes of the plant. As I said, artificial intelligence that will help us be able to do those kind of engineering jobs that don't lend itself to a cookie cutter approach. I call it bespoke, so custom kind of stuff, like sequences, like advanced regulatory control, some complex cascade loop, or some model predictive control. We can use AI to do some of that and help simplify that approach. Now, one point that I didn't mention very much about this digital workflow is that we can generate or push the data backwards. So if we've done this control engineering, and let's say during the commissioning, we changed the alarm set point on one of the loops, or we changed the engineering range because some of our input data was wrong, or we added a new loop, then we can push the data backwards and actually use that data to then be consumed or ingested to help create as-built documentation. So it really is this data, the utilization of data in the engineering workflow is a fabulous boon to be able to improve our efficiency at the front end for generating controls, for testing and validation, and then providing as-built documentation. I'm not sure about you guys, but when I was working and we had payment milestones, the delivery of those as-built documents, that was generally a pretty big milestone, as was commissioning. So we want to get paid on a timely fashion. So the better we can get at improving our schedule, the faster we can all get paid, which is great. So that's it for me today. I just wanted to leave our contact details as the last slide. By all means, if you have any questions, don't hesitate to give me a call or drop me an email. And I put Hal's contact details there as well, Hal. And with that, I think I'll hand it back to you, Russell, for Q&A. I wasn't able to monitor the chat.
We actually haven't had any questions come in from the audience yet, but I did have a question could you just recap some of the tools that our systems integrators might have that will currently work with this? You mentioned a few in your presentation, obviously Excel, but what are the other software packages that can be used today with this function?
Yeah, well, anything that can create essentially a CSV file. So Hexagon, Smart Plant is their product. They make a piping and instrument diagram tool, as well as an instrument management tool. I think Siemens have one called Comos that does a similar job. I'm not familiar with the Rockwell tools, if they have similar tools. If customers have legacy data, let's say I was doing a replacement of an older DCS, for example. If I can export all of the data from that older DCS, I could pass that through as a comma separated file. And we use these tools a lot for doing migration of obsolete systems. The world is really your oyster on this front. There are other tools that have valuable data in them as well. Alarm optimization tools have engineering ranges and those kinds of things. So yeah, there's quite a range, Russell. I don't have a list prepared, but I think that sounds like something I should prepare for future.
So if that's the end, Russell, I don't know if you still had more questions you wanted to stump Hal with, but now's your chance.
No, I didn't see any audience questions come in at this time.
Okay. Great. And I just have a few last minute things to say to folks here. First, I want to say thank you to our speaker, Grant and Hal and Russell, for this informative discussion. And also thanks to Graybar for sponsoring this event. And of course, thank you for attending. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thank you for joining us today and Happy New Year. Bye.
Happy holidays, everybody.
Yeah.
Thank you very much, Lisa. Thanks, Russell,
Okay.
Hal. Bye-bye.
Bye-bye.